In this video we present our work on flexible stereo, a framework for constrained, non-rigid, wide baseline stereo vision for fixed-wing aerial platforms. Fixed-wing UAVs need long-range depth estimates to give controller and actuators enough time to safely avoid obstacles. The wings of fixed-wing UAVs naturally offer this required wide baseline for stereo vision. However, during the flight, the wings show significant vibrations and flapping behavior. To estimate this time-varying baseline, we propose to use an efficient EKF formulation to fuse a probabilistic wing model with the visual-inertial measurements from two sensor rigs which are attached to the wings. The EKF formulation is based on previous work, where two quadricopters are each equipped with a camera and an IMU. Instead, for our application, the visual-inertial sensor rigs are attached to the wings of the fixed-wing UAV, and a Gaussian-based baseline briar constrains the relative transformation and filters outliers coming from the relative perspective endpoint estimator. Given the optimized relative poses, stereo block matching is employed to generate the depth maps. The flapping wings of the unmanned aircraft are modeled as a combination of a periodic and a random force. In gazebo, these forces generate additional roll and pitch motions on the wings. The framework's performance to generate accurate relative pose estimates and depth maps is analyzed based on photorealistic synthetic datasets. In this video, the top row shows the left and right image of the stereo pair. The bottom row plots the depth maps obtained from ground truth poses on the left. The bottom right shows the depth maps obtained from poses with a fixed nominal relative pose assumption. Depending on the magnitude of the disturbance and motion of the UAV, this depth map potentially contains no useful information. In contrast, our proposed framework is able to generate highly accurate poses even with noisy IMU measurements and dropouts of the PNP estimator. While the two IMUs fused with an EKF precisely estimate the deformation of the relative baseline transformation in the short term, the probabilistic wing model ensures a constrained estimation problem in the long term.